Hi, Eric. So good to be with you again, my friend. Here we are again with a new masterclass. And so thanks for joining today. And why don't you just take off and tell all of our community members and engineers out there about your new S-Parameters Masterclass?
Right. So I have to say, S-parameters are probably one of the most important kind of tools that we use to describe interconnects, and one of the most either confusing or hard to understand because of the way they're often taught. And S-parameters is, yes, I always say that there are three kinds of models that we use to describe the electrical properties of an interconnect. There's lump circuit elements if the structure is electrically short. There's distributed or transmission line elements, circuit topologies, if the interconnect is electrically long. And then there's a third way of describing interconnects, and that's in terms of S-parameter behavioral models. In principle, everything you ever wanted to know about the electrical properties of an interconnect are in their S-parameters. They come from either measurement from a network analyzer, for example, or from simulation. Every electromagnetic field solver, when it simulates and says, oh, here's this geometry, here's this via or transmission line or connector, some structure, and I want to solve Maxwell's equations and get the electric fields, the information that comes out of it, you get pretty pictures, but the real information that you use are the S-parameter models. And so it has become kind of the medium of exchange of electrical information. And so I find that most engineers don't really understand what's in that black box. They just treat it as a black box. And so over the years, I found that if you understand a little bit about the patterns that you see in the S parameters, it tells you a huge amount of information about the nature of the interconnect and the features in the interconnect. And if there are problems with the interconnect, you will see them in the patterns in the S parameters if you look at it. And so over the years, I developed a series of lectures about, it's really about reading the patterns that appear in the S-parameters, the return loss, the insertion loss, the crosstalk terms, looking at them in the frequency domain, in the time domain, as single-ended or as differential. That when we talk about S-parameters, it's really the combination of those four different perspectives. And every question you want to ask about the interconnect, the answer is in one of those four different representations, and then each S parameter, if it's a 4-port, you got 16 S parameters, one of those 16 S parameters in one of those four domains typically has the answer to the question. It's just that, oh my gosh, how do you know which one to go to? How do you know how to display it? How do you look at them? And that's really what this course is about, starting from really the basics to delve into how to display the S parameters, and then looking at the specific patterns. And that's why we call it reading S parameters like a book, that you look at the patterns, and the patterns tell you about the kind of features that you should see in the interconnect.
So, who is this for? Like, what type of engineer? It seems like everybody would be interested in this data. But can you tell our listeners and our, who is ideal for this to take this course?
Right. So it's invariably going to be signal integrity engineers, hardware engineers. If you currently use any field solver results or get measurements from somebody else on your team, you're using S parameters. So S parameters are being touched by more and more engineers in a system. And even if you deal with just TDR, TDR is actually one of the S parameters, is the return loss in the time domain. And so even TDR results are S parameters, and we cover that a little bit. So if you're already an expert and you understand all the bases of S parameters, and there's a very famous book by Posar on microwave engineering, where that's one of the best high-level technical books about S parameters. Pete Poupalakis wrote a book a couple years ago on S-Parameters for Signal Integrity, which is a compendium of everything you ever wanted to know. But every page is like 10 equations long. So it's everything is there, but sometimes it's tough going. If you're familiar with those books, Posar and Pete's book, and you're comfortable with that, this course is not for you. you're not going to get much out of it. But if you've been struggling, where do I get started? I mean, I hear about S parameters. I have to use them. They're a black box. I look at it. They're just a bunch of numbers. I see these squiggly lines on the screen. I don't know what any of this means, but there are clearly some patterns here I'd like to understand. That's who this course is really for. And I found over the years, I've been doing this for more than 20 years, to engineers, it is immensely valuable if you can, instead of just blindly taking the S parameters and moving them from one simulation to another, open them up and kind of peer inside and get a feel for what those patterns mean. And, unfortunately, not all S parameter models are good models. And the more you can understand the patterns that you should see and consistency tests, the better you're able to evaluate, is this a good set of S parameters or not? And so for this particular series of lectures, I use Keysight's ADS as the vehicle to simulate the S parameters. We can simulate them from circuit topologies, and we can also read them in from measurements or from EM simulations, and then display them in these 4 different formats. And so I use ADS as a really simple, easy to use tool that allows us to do the synthesis or do the display of the S parameters and see those patterns. And so I walk through examples of how we can create S parameters. You vary a feature in the interconnect and you see, that's the impact that we see in the S parameters. And we look in the frequency domain, the time domain, single-ended, and differential.
Eric, for my little 5 or 6 years that I was heavily involved in RF PCBs, when I think of S parameters, that's where I was first introduced to S parameters, and that seemed like that's where a lot of people talked about S parameters. But so help me understand, and maybe somebody else like me, sort of the thing between the frequency domain and the time domain and how those apply, maybe say in high speed digital as well as frequency. Just a quick treatment is more for me than anybody.
So it's even more complicated than that because I get a lot of RF engineers that are kind of retread into signal integrity.
Yeah.
And there's so the main difference between RF and SI is the bandwidth. RF is narrowband. I care about the impedance at one frequency. I care about the behavior of an interconnect in one very narrow frequency range. I look at the S parameters in a relatively narrow frequency range where the behavior of my RF circuit is.
Mm.
And so I think about the world in a narrow frequency range, at the carrier, plus or minus modulation, or I think about it just in the frequency domain. When I look at S parameters, it's a narrow frequency range. I'll look at Smith charts because that tells me a lot about impedance matching at particular frequency. All of that is totally irrelevant for SI engineers.
Yeah.
And that's not to say that the frequency domain is not important, but for SI engineers, all the signals that we deal with are relatively high bandwidth in the sense that,
Mm.
yeah, they have some high frequency that could be in the, tens to 100 gigahertz kind of frequency range, but they extend all the way down to DC because the data patterns will sometimes have, long ones and zeros. We have to worry about the high bandwidth properties of the interconnect and high bandwidth S parameters. And we will often want to display the S parameters in the time domain as TDR, for example. The problem is, unless the S parameters are set up correctly, it's difficult to do that Fourier transform into the time domain. And the secret is, when you're doing the setting up the S parameters, simulating them or measuring them, you're going to have discrete frequencies that you look at, either measure or simulate. And you want the first frequency to be the same value as the step frequency for all the others, and you want to have them uniformly distributed. So if you're going to start at 10 megahertz, you want to go to 20 gigahertz, you want to do 10 megahertz with 10 megahertz steps. And that way, when you do the Fourier transform, the transform is looking for equally spaced frequency intervals and the first value equal to the space. If it's not that, it's going to interpolate to get to those points. And in engineering, we say interpolation is just a really fancy name for makeup shit. And I guess
Reminds me of your video about the interpolator.
yeah. And so when you are setting up the S parameters, setting up the VNA, you got to be careful of how you set it up so that you can then also take that data and display it in the time domain. And so that's really the big difference is we're dealing with wideband signals. We're dealing with the whole large frequency range in the S parameters starting in a certain way. And we're also going to look at the time domain response of the S parameters. Same exact data that's in the
Yeah,
frequency just redisplayed with mathematical transform into the time domain. Exactly the same data, but we gain more useful information
I
just by
see.
inspection.
Well, is it then I mean, it sounds like from what you've said, it's people, designing hardwares or doing SI are really the ideal, audience for this, but is it also helpful for ARF engineers?
Um, if I was an RF engineer, I wouldn't waste my time with Bogatin. I would spend my valuable time going after, materials like Posar's book and Balanis's book on antennas. And I have to say I haven't kept up much with RF system
Yeah.
design, but IMS is hugely popular, and there's
Yes.
so many great tutorials there. And so I would focus more on those areas just because you'll learn about impedance matching in a Smith chart, and that's not something
Right.
an SI engineer cares about. The insertion loss, the return loss, you're going to worry about that in terms of narrow band and the impact of an antenna, which is not covered in any of the SI parts. So I'm not sure you would gain anything unless you worried about the signal integrity quality of your interconnects and wanted to look at it wideband.
Okay,
It's
good.
really for SI engineers.
Okay, very good. So, do you remember how long I uploaded all these videos and all that? I know it is 4 modules and there's 3 lessons in each one. Do you happen to recall how what the runtime is on that?
Yeah, I tried to keep it in like 10 to 15 minutes per module, but not always successful. So I'm going to guess it's at least an hour for each of the four different
Okay, so
courses.
still well, which means it's easy to get through. That's what I
Yeah,
wanted to get to. So
yeah.
it's um for people wanting to take this, it's not going to take a huge time investment, but it will really help you understand how to read S parameters like a book and recognize those patterns. So that's a good insight. And also for our listeners, this is absolutely free thanks to our sponsors like Rode and Siemens and Keysight. So this is 100% free. It's taught by Bogatin. You can go to the doubleecosystem.com and click on the masterclass tab. And we have 3 masterclasses now. We've got Transmission Lines 101, High Speed Digital Design, and now the S Parameters course, which is now open for pre registration. The course will actually open on the 2nd. Eric, is there anything else you want to let folks know in regards to the class, the value of the class, um,
Yeah,
anything
so
along those lines?
if I had to summarize in kind of one sentence is if you use S parameters now and you feel intimidated by, all the math that everybody talks about behind it, and when you open it up, they're just a bunch of numbers. If you're intimidated by S parameters, you want to view the lectures in this masterclass workshop. And after viewing these lectures, you will never be intimidated by S parameters again.
That is a good way to wrap up our conversation. I love it, which is what you're so good at is making people breaking it down into understandable formats. So, well, Eric, thank you so much for creating this course and for working with me to make it available to engineers everywhere. Hopefully, we'll have another conversation before Design Gone gets here. But thank you again for your time and putting these materials together. And let's talk again soon about DesignCon.
Sounds great.
For our listeners, I'm gonna put everything in the show notes for you. You can go down and check there, or the very easy way to tap into this is thedoubleecosystem.com. Click on Masterclass, and you'll be good to go. Thank you so much for joining us with this conversation with Eric Bogatin on his new course, How to Read S-Parameters Like a Book. We'll see you next week. Until then, remember to always stay connected to the ecosystem.